Guys, in this video, we're going to go over a few of these trig identities and how, following the guidelines, how we can simplify and verify them. It says for all values of theta for which the expressions are defined, prove the following are identities. Okay, so we have 2 over secant of x equals 2 minus 2 sine squared of x over cos of x. So looking at the two sides of the equation, I would definitely say that the right side of the equation is the more complicated side. So we're going to try and simplify the right side first. All right, so looking at the right side here, 2 minus 2 sine squared x over cos of x, we can factor out a 2 from that expression. So it'll look like 2 and then 1 minus sine squared x over cos of x, and then 2 over secant x. Okay, and what I like to do is like to make it very apparent that, like, again, with any trig identity, you can't move terms over from one side to the other. I just draw one big long line so that way I know that I'm not adding, subtracting, multiplying, or dividing terms over from one side to the other. All right. So that way I just know that I'm going to keep, for our problem here, I'm just going to keep on working on the right side and simplifying it. So we'll have, if we take a look at this expression here in the numerator, we have 2 times 1 minus sine squared x over cos of x. And this value here should ring a bell and be like, that kind of looks like a Pythagorean identity. So 1 minus sine squared x, that's actually equal to cos squared. So I'm replacing that value there with cos squared x. So we'll have 2 times cos squared x over cos of x. And then it'll be equal to 2 over secant x. Okay. And what we can do is we can actually cancel out one of the cosines, because this is technically cos squared. So we can cancel out the cosine in the denominator, and we'll have 2 cos of x equals 2. And then what I'm going to do now is I'm going to rewrite secant so it's in terms of cosine. So it becomes 2 divided by, and then secant I'm going to change as 1 over cos. Okay, so dividing by cosine on the left side, that's the same as multiplying. So it becomes 2 cos of x equals 2 cos of x. All right, so that first identity now is verified. So with these trig identities, you can always like kind of have a little bit of your own version of steps to get there. But I think this would be kind of the easiest way, because you have 2 divided by secant. That's the same as multiplying by cosine, because they're reciprocal functions. And that's how we can eventually get the two sides to match. And that's always what you want with the trig identities, is you want the very last steps here to be matching on both sides of the identity. All right. So let's take a look at number 2 here. We have 1 plus sine of theta over cosine theta plus cosine theta over 1 plus sine theta equals 2 secant theta. So we're adding our fractions together. All right. So whenever we're adding fractions together, we need to get a LCD. So what we can do, our LCD is going to be cos theta times 1 plus sine theta. So what we're going to have to do is multiply this first term. We're going to multiply both times 1 plus sine theta over 1 plus sine theta. So you'll have Let me do it like this. So it'll be 1 plus sine theta here, cos theta for this first fraction, and then we would multiply cos theta to the numerator here and to the denominator. So we would have this becomes cos squared because cosine times cos becomes cos squared theta over, and then we would be multiplying cos theta here to the bottom, cos theta times 1 plus sine theta, and then equals 2 secant theta. So again, I'm just going to kind of draw a line here to show that I'm not moving any terms over. All right, so I just fixed it a little bit. So what we have to do in the numerator here, we have to FOIL this out. So this becomes 1 times 1 is 1 plus, and then sine theta and another sine theta gives us 2 sine theta, and then plus sine squared theta, right? Because we're multiplying sine times sine afterwards. And then plus this cos squared stays now, plus cos squared all over. And then now we have our common denominator of cos theta times 1 plus sine theta. And this is still equal to 2 secant theta. I'm just going to kind of draw an arrow from here on down. Now, we FOIL this here. So now sine squared plus cos squared, that is a Pythagorean identity that we can simplify and substitute. That's equal to 1. So I'm just going to rewrite this now. It's 1 plus 2 sine theta plus sine squared plus cos squared. We're going to replace that with just 1 over cos theta times 1 plus sine theta. And again, equals, it's going to keep on putting that arrow down. 1 plus 1 is 2. We can combine those terms, so it becomes 2 plus 2 sine theta over cos theta times 1 plus sine theta. All right. Let me zoom in a little bit here. So now this here, you could probably start to see what's going to happen. This becomes, you can factor out a 2. So we'll have 2 times 1 plus sine theta times cos theta 1 plus sine theta. And you're like, ooh, I can cancel that out. And then 2 over cosine, that is the same. So 2 over cosine, right? Because remember, secant is the reciprocal of cosine. 2 over cosine, we can rewrite this as 2 secant theta. So I'm just going to kind of arrow it over here. Terrible arrow. So it's just going to be 2 secant theta is equal to, and then we didn't even touch the right side, but it's verified now that the both two sides are equal. So you can see how when, especially when we're dealing with multiple terms, where it can get a little bit messy with the algebra, but if you stay patient with it, you can eventually see that the identities are going to be equal. All right, let's do a couple more. All right, so we have cos of theta plus sine of theta quantity squared over 1 plus 2 sine theta cos theta equals cosine theta times tan theta times cosecant theta. So I'm just going to work with the left side first, and we're going to have to FOIL that numerator out. All right, so I'm going to write down kind of the FOILed out version. So remember, this is really cos theta plus sine theta times itself. So when you're writing it and FOILing it out plus sine theta, just keep this in mind as you're multiplying the terms together, that this is what you're multiplying together. Okay, so I'm going to write it out here on the bottom. So if we're FOILing these two terms out, cosine times cos gives you cos squared, cos times sine gives you cos times sine, and then you have sine times cos. So that's where we get this middle term from, because there's two of those, like sine times cos terms, and then sine times sine gives you sine squared. I didn't do anything with the denominator yet, and I didn't do anything with the right side yet, right? But it's still equal to cos theta times tan theta times cosecant theta. So same thing, we're gonna draw like a line all the way down the middle of the equal sign here. And we see that there's going to be another Pythagorean identity. Cos squared plus sine squared, that's 1. So you have 1 plus 2 sine theta times cosine theta over 1 plus 2 sine theta cos theta. And you're looking at this and you're like, wait a minute. You're talking to yourself and you're saying, self, these look the same, and you're not going crazy because they'll eventually both of these will cancel out. You're just left with 1. So we'll get to that in the next step, but we're going to have to rewrite the right side now. So I'm just going to rewrite this in terms of sine and cosine, right? Because that's kind of like our default move, because we can rewrite tangent as sine theta over cos theta. And then we can rewrite cosecant theta as 1 over sine theta. And you're looking at this all like, ooh, I can cancel stuff. Cos goes away. Sine goes away on the right side. And then on the left side, all that also goes away. So you're just left with 1 equals 1. So all that work to just basically end up at 1 equals 1. All right. And sometimes that's kind of the frustrating thing with identities, is that you have like this big jumbled looking mess to start with, but then at the end it can kind of just work itself out. All right. And let's take a look at this last problem here, number 4. Tangent theta plus cotan theta equals secant theta times cosecant theta. Well, tangent and cotangent, secant, cosecant, I'm going to write everything in terms of sine and cosine. All right, so this is everything rewritten in terms of sine and cosine. And we see on the left side that we're adding fractions together. So we're going to have to get a common denominator. So it looks like it's going to be cosine times sine. We're going to multiply the numerator and denominator of this first term times sine. So that'll give us, instead of sine there, it becomes sine squared. Sine squared of theta plus, and then we will multiply cosine times sine. Sorry, cosine times cosine, so that'll give us cos squared. Cos squared theta over cos theta times sine theta, right? Because we had to get our common denominator, equals 1 over cos theta times sine theta. And it's that same Pythagorean identity. Sine squared plus cos squared, that's just 1 over cos theta times sine theta And it matches up now, equals 1 over cos theta times sine theta. And there you go. All right. So 4 examples going over how to use the trig identities.